Thank you. Can you hear me? Thank you for this very kind introduction. First of all, I would like to say I feel particularly privileged to be here and connected to this topic and the venue. I'm an environmental scientist by education, and I've dealt with contaminants in soils for many years. Also, my father graduated in agricultural sciences here at the University of Piacenza, so I'm very glad and proud to be here today. So our topic is the work of EFSA in terms of risk to human health for the presence of micro and nanoplastics in food. First of all, I would like to start with explaining who EFSA is and what we do. I'm sure that you all know what EFSA is, but we find that sometimes it's a bit unclear what we do and what we don't do. Then I will explain a little bit about the content panel statement from 2016, which is sort of setting the ground for the work that follow up within EFSA in terms of micro and nanoplastics in food. Then we speak about the scientific colloquium from 2021, a follow-up project with the BFR, and just some an upcoming event and some opportunities. So EFSA is the European Food Safety Authority. It is the reference body for risk assessment in food and feed in the European Union, and the work that EFSA does covers the whole food chain, so from farm to fork. It is one of the bodies responsible for food safety in Europe, and the way the work is delivered is by protecting consumers, but also protecting the health of animals, of plants, and the environment overall, by giving an independent and transparent advice on the risks of the food chain, within the food chain. This translates in what EFSA does and what EFSA doesn't do. So EFSA provides an independent scientific advice to the risk managers and the European Commission in terms of food and feed safety. EFSA is also providing a risk communication and tries to promote scientific cooperation. What EFSA doesn't do is developing food safety policies and legislation. We do not adopt any regulation or authorize marketing of new products, and we don't enforce any food safety legislation. To be able to provide the scientific advice that I just mentioned, EFSA works with 10 scientific panels, plus a scientific committee that deals with cross-cutting topics. One of these panels is the chemical contaminants panel, or content panel as we like it. The content panel provides advice on contaminants in the food chain and in general undesirable substances such as natural toxins, mycotoxins, and environmental contaminants. It's made of 17 members, and these members are external to EFSA, they're not staff, and they are selecting based on their expertise. They are also selected to be able to cover all the disciplines that the content panel needs to be able to handle, let's say, to be able to deliver a risk assessment. Obviously, the content panel works following the typical risk assessment paradigm. So the content panel will identify the hazard identification, the hazard characterization, and exposure assessment. For the exposure assessment, obviously, we will need occurrence data, and the occurrence data is generally submitted to EFSA in the EFSA database or is collected by literature. And together with food and feed consumption, this allows us to derive an exposure assessment. The hazard identification and characterization, I'm sure a lot of you are very aware with this and familiar with this topic, but we will need to collect information on toxicokinetics, ADME, animal toxicity, epidemiological studies if we're dealing with food and not feed, mode of actions, and those response relationship. These two aspects put together allow us to characterize the risk. To characterize the risk, we would compare exposure and hazard, or use different techniques which include the margin of exposure, for example. Now, in 2016, the content panel was tasked with a mandate from the European Commission. This was a result of a request by the German Federal Institute for Risk Assessment, also known as BFR. And the idea was to have a scientific opinion in which a risk assessment for the presence of micro and nanoplastics in food, with particular focus on seafood, for the reason that I'm sure you understand. Yes, so the risk assessment, the opinion was supposed to include a risk assessment. The panel started working on this opinion, and the evidence that was collected actually didn't allow to run a risk assessment. The chronic lack of data and knowledge on micro nanoplastic resulted, rather than in scientific opinion with the risk assessment, in a statement. And the statement actually, for us, is a starting point, because it lists all the gaps, data and knowledge gaps, and recommends what should be filled to be able to then eventually start run a risk assessment. So briefly, the data and knowledge gaps that were identified are, let's say, very simple. So in terms of microtoxin in food, it was identified that there were some analytical methods. However, the occurrence data was scarce, whilst for nanoplastics, there was no occurrence data in food, and there was no methods that would allow to obtain this data. On the other side, and probably as a result of this, there was no information on toxicity, and there was no information on toxicokinetics, so what happens when these particles are ingested. This was both for micro and nanoplastics. Obviously, the recommendation followed from there, so the content panel recommended that analytical methods should be developed. They should also be standardized, and the quality assurance should be put in place and demonstrated. This is something that came up already last night. To be able to compare data and put it all together, we need to make sure that we are comparing like for like. Occurrence data needs to be generated, in particular for the smaller particles, and including food processing. So we would like to know what happens when the food materials, for which we know the occurrence data, so we know how many microplastics there are in this sample, what happens when this sample is cooked. That is very important. So research should be focused on toxicokinetics and toxicity as well, including the gastrointestinal tract and understanding the local effects in the gastrointestinal tract. In addition, it would be interesting to know what happens to microplastics when they are in the gastrointestinal tract. Are they degraded? Do they become nanoplastics? What happens after that? So there is a lot to be investigated here. So following this statement, EFSA understood that there was the need to put together the risk managers, so the commission, the risk assessors, and the scientific community to be able to come up with a coordinated approach. So in 2021, there was a scientific colloquium, which was titled Coordinated Approach to Assess the Human Health. It was probably a year late than anticipated due to COVID, and it was also only online, unfortunately. This put together, as we said, the risk assessors, the risk managers, and the researchers with the idea of understanding the state of play and understanding the ongoing research, how to foster collaboration, to be able to start filling these gaps and eventually running a scientific risk assessment for human health. This goes a bit more into detail. The idea of the colloquium was to identify what had changed from the 2016 statement, to anticipate collaborations, interesting to understanding what were the challenging to considering a full life cycle system for the risk assessment. So not just risk assessment focused on the microtoxins in food, but on the microtoxin in the whole cycle. to stimulate priorities to generate data. So what was more important, what should be done first, to be able to then assess risks. Also, how the data can be then made available to the risk assessors and the risk managers. Often we realize that it's difficult to collect data from research. And also perception. The perception is something that we'll touch in a minute. The perception overall can actually, and I'm speaking about the society perception, can provide priority settings for this issue. There were 3 breakout rooms in the colloquium on analytical method, on exposure and hazard identification and characterization. In terms of analytical methods, it was identified that it is needed to quantify both the number and the mass of the particles. Interestingly, coming from the nanomaterial research, they realized that when a methodology is developed to fit a definition rather than the needs for risk assessment, then it doesn't really work very well. There was a suggestion that probably was worth focusing on the main polymers used in food and the practicality of the analytical methods. This is something that was touched earlier on as well. And also perhaps a combination of methods would work well to be able to fill this gap. In addition, the development of reference materials, it was identified that would take a number of years, but probably the directorate from the JRC would be able to assist on this topic. In terms of exposure to humans, it was identified that the total exposure via food needs to consider different sources. So starting from the farming practices down to the particles that are originating during manufacturing, processing, packing, storage, cooking, and surface deposition. It was also identified that there is the complexity of measuring the rate of leaching and the release from food contact materials, and that there is an additional step that it's adding complexity, and that is the determination of internal exposure after ingestion. And obviously this, we are talking about food, so overall the relative importance of the different pathways remain an open question. So once we identify what is the risk for ingestion of food which may be contaminated by micro nanoplastics, we don't know what is the relative importance of other pathways, so inhalation, as we were saying yesterday, for example, or maybe direct exposure to the skin. Just quickly through this, the last group identified further gaps and suggested some actions to be prioritized. As we said, the standardization of testing and testing materials, identification of bioavailability and bioaccumulation and adverse effects. It was identified that it's quite difficult to obtain homogeneous materials in terms of chemical composition, size and shape, and in particular for secondary micro nanoplastics. Existing data should be used, so that the experience from the nanomaterial and the nanoparticle field should be used. And also there was the idea that we could use expert knowledge. So rather than going straight into toxicological testing, we could be formulating a hypothesis based on expert knowledge, and then direct the efforts towards verifying that hypothesis rather than, as I said, doing toxicological testing. And also the weight of evidence approach could probably be an option. So overall, there was a significant progress compared to the 2016 statement. However, the scientific evidence on human health effects from micro nanoplastics is still scarce and of variable quality. There is a large list of uncertainties, and that needs further effort to generate data and start filling the gaps. Overall, the problem is complex, is an interdisciplinary problem, and it's global. So it was identified that There is the need for different stakeholders. There is the need for a coordinated research initiative, international cooperation, and it is needed to address risk perception and the stakeholders' priorities. This is the publication of the event report that is available on the EFSA journal. Now, on the perception of risk, as we saw at the beginning, EFSA is dealing with risk communication as well. And risk communication needs to be clear and accessible to be able to address the citizens' concerns. The only way to address the concern is to understand them. And so research needs to be put into understanding in terms of microplastics, what are the factors that are underlying the concerns in absence of scientific information on human health risks. So there is no information on human health risk, and yet the society is very concerned. So EFSA ran this project together with the BFR with the idea of understanding the perception of microplastics and improve risk communication. This was done in two phases, a phase of interviews and a phase of survey. It's quite recent, so the first phase has been published, but not the second phase, so that we can have a look at the high-level conclusions of these two phases. So in the first phase, it was identified that there is a high level of uncertainty, a negative perception of microplastics, so it's not clear what the mechanism behind the microplastics. It's sort of naturally people are using the plastics knowledge and transfer them to the microplastics to understand the phenomenon. There was an understanding of accumulation and dose-response relationship, but overall a feeling of helplessness and the idea that a solution needs to be found to address not just human health but also the environment. The survey, I didn't mention that the interviews only involved 15 people in Germany and 15 people in Italy, because of Italy is where EFSA is based and the BFR is based in Germany. The survey involved just over 1,000 people in Germany and the same in Italy. So the output of the survey shows that there is a high level of concern for the hazard that microplastic can impact the human health and the environment. There is a various level of understanding of what the matter is. There is a perception that we are getting exposed to microplastics through consumer behavior, so consuming food or using cosmetics. There is also the idea that by reducing plastics, we probably reduce microplastics, and that the responsibilities to connect this is coming from the industry, but also the EU and the member states, and that overall the individual actions are not particularly relevant. This is the publication of the first phase, and the second phase will be coming soon. This was what I wanted to tell you about the work of EFSA on risk assessment for the presence of micro nanoplastic in food. But I also was asked to let you know about an event which will take place soon in Parma. So EFSA is hosting the Global Summit on Regulatory Sciences in a couple of weeks' time. It's in the EFSA building, which is, by the way, not the one in the picture, just in case you were wondering. The registration is closed, but it is possible to register to take part to follow remotely online. And also, in case you were particularly impressed with EFSA and what EFSA does, and you wanted to contribute to food safety, there are a couple of, actually 3, jobs open at the moment, 3 calls. They're expiring soon in the next 2 or 3 days. So if you were interested, you'd rather have a look today. But there are always opportunities, not just as a staff, but also as a seconded national expert. And also it is possible to take part to selection for the panels, which is something in addition to a day job, is not a full-time position. So yeah, that's me.
Thank you very much, Elena.
Thank you.
We have time for a few questions. No, wait just for the mic. So you can hear better.
Just a question. When we applied for a European project, some of them they asked us to collaborate with EFSA, but EFSA cannot be partner of that project. But what the collaboration could look like after the acceptance of the project, or how it looks like?
I don't know. This is a very technical question for our human resources. I don't know. It depends. Is it a call for, or is it? So EFSA has got a number of projects. A way to involving different stakeholders is to run projects where there are different partners. So maybe that's what they mean, to collaborate with EFSA on a project. But I'm just guessing.
Hi, thank you for the very informative presentation. My question comes as an outcome of this conference. Is anything planned in EFSA about the potential environmental risk assessment of microplastics? Because we know that the EFSA is involved in the regulation and the risk assessment of other contaminants. So I expect this microplastics are really serious environmental contaminant, really emerging one. I would suspect that there should be some need or forthcoming need for regulating microplastics. And are you having anything in mind about this or any thoughts?
Yeah, it's a very complex question, but in a nutshell, to be able to perform a risk assessment, we need information, we need evidence and knowledge. So if we were to receive another mandate from the Commission to assess the risk connected with micro nanoplastics, we would still need data. So I think it's a bit premature. On the other side, environmental risk assessment is only connected to a few pieces of legislation. So we perform environmental risk assessment for feed additives, for example, or obviously for pesticides, and a few other very specific topics that have been regulated in that way. We could decide to have a self-mandate, so we would decide to run a project to be able to define the risks connected to micro nanoplastics, but that will need data. Yeah, so to be able to, as I said at the beginning, we provide scientific information that the Commission need to enforce and come up with actions to be able to limit product or try to reduce contamination and so on. But also they need evidence to be able to work. So I'm here to say, yeah, please, could you focus on food as well and yeah, continue trying to fill these gaps that will allow us to really understand what is happening. And as we see, there is a very strong feeling towards microplastics in the society, and but we don't know how to answer to this question that we always or often are asked about risks.
Okay, thank you, Elena. I'm sure, since we are a little bit late, I will stop now with the questions and ask Elena to answer you during the coffee break or other parts of the conference.